Hello, my name is Ron Andrews and I'm going to describe to you today the electron gun. More specifically, the mechanism of the electron gun that creates and focuses the electrons. It might sound like the electron gun is some obscure, sciencey technology that not a lot of people have encountered in their lives. I thought the same thing until I found out what the electron gun was and that I'd actually been living with one in my house for my entire life. That's because televisions use electron guns. Electron guns shoot electrons, and in television they shoot electrons in a specific pattern, and the specific pattern of electrons hits the screen and lights it up, and you see an image. In the electron microscope, the electron gun shoots electrons at a specimen. The electrons bounce off of that specimen, and from the way that bounces back, we can make an image. And because electrons are so tiny, we can take images of very tiny, very, very tiny things. The electron gun doesn't have to be large at all. It can be the size of a roll of quarters, so no bigger than a few inches. The electron guns basically just require that you have a long cylinder for the electrons to travel down, and that this long cylinder is held at a vacuum. You need the electrons to be able to pass through air without any other molecules in it, so we make that cylinder a vacuum, much like a light bulb. Now the main way it works, we start with a power source. And the power source runs electricity through metal. And so, much like a light bulb, we have two metal elements and a filament between. In the case of the electron microscope here at CVTC, we use a tungsten filament. Tungsten is a metal that has a very, very high melting point, so this tungsten filament isn't going to melt. So we run electricity through here, and the tungsten filament is made to be a very small point. The tungsten filament itself is very, very thin in diameter, about the width of a human hair. The electricity runs through and it heats up the metal of the tungsten filament, and it basically boils out electrons. So the electrons come shooting out of it. And the trick of the electron gun is to capture these. So the next step we take is we create a cylinder around it. It's called the went-out cylinder. This went-out cylinder has the same charge as electrons, which is negative. So it focuses them out into kind of a ray. And they bounce out in a fashion that then it shoots at a specific direction. The next trick to the electron gun is to take this ray coming out of the went-out cylinder and accelerate it. Now the way we accelerate it is we take a positive charged metal cylinder plate, a metal plate cylinder, and you can see this is the cross section here, and the electrons pass through, but they don't just pass through, they're kind of pulled through because it's a positive charge. And this pulling through accelerates them to almost the speed of light. It's important that they have high energy to light up a TV screen or to bounce back accurately off of a specimen in the electron microscope. Now this all takes place in a vacuum, and this anode plate, you can repeat the process several times. In the electron gun, the electron gun in the television just needs to shoot down a line and it ends with a light up image. But in the electron microscope, we have more elements at the end here, which can make this beam move specific ways by using magnets and more electricity. The electron gun has been so common in our lives that I think it's kind of interesting to find out that TVs use them, and it's really not that complicated of a process. It's similar to a light bulb. The TVs nowadays don't have them as much, but it's kind of interesting now when you understand the electron gun to see a TV and be like, wow, it's like a gun of electrons shooting at the speed of light, and I see an image. I've been having a lot of fun using the electron microscope here at the school, and I hope that it's giving you guys some insight into how science works for us. Thank you very much for listening, and have a good night.